wing sweep. Right now, contribution of wing sweep. Contribution of wing sweep to E. This decides the level of stability. CL prime was the amount of stability, amount of coefficient of rolling movement. So level means this parameter should be looked at. So what actually we are trying to look at now? Suppose what is the effect of keeping swept back wing sweeping is swept back wing, especially talk about. Wing sweep is, what is the effect of wing sweep or swept back on roll stability? How to check this? Let's look at the image first. Then we'll. This also has to be understood very technically, as we looked at for diagonal. What is the original direction of V infinity? This is V infinity original. This particular wing sweep or swept back wing is oriented to is it encountering disturbance or it is the original position? Why it is moved this way? Why the image is made like this? Previously we could not make it because of diagonal image. So swept back wing is oriented originally like this means what is the original V infinity? Original flight direction. V infinity. So it has, this picture itself is what? This picture is with positive side slip. That means this wing is already, tell me about the roll to right, which we are not able to show. This wing is rolled to right, that's why it experienced positive side slip. Then we have to analyze. What is that you have to show? Because of the wing sweep, this particular wing swept back wing hole configuration should be able to create roll to right. Roll to left should be able to create. Okay, that we are not very sure, sir. We are confused. Finally, the mathematically dou CL prime and dou beta should be negative. Restoring rolling moment should be created by the arrangement of wing sweep. I basically mean swept back wing. This will investigate mathematics. What is the idea? This should, otherwise this is not an idea. Does it create a stabilizing contribution or destabilizing contribution? We have to ask. Okay. Make the sketch. Step by step we will make it. So let me make this is the V infinity. So this is the plane of symmetry and this is V infinity. What kind of side slip we can encounter? Positive. Right wing is what is this? What is the condition, right, of right wing? Is roll to right is already created. Is it understood? This picture involves right wing is roll to right also. Otherwise, this particular positive side slip is not created. Okay. Let us investigate this situation. To the reference or draw a parallel line to this, I will explain now. This is called swept back angle, lambda, capital lambda. So wing sweep angle is represented by capital lambda. Okay. Now Look at the picture now. There is a line called quarter chord line. That is also a reference. It's okay for me if you take this line is a reference line, leading edge line also. But usually quarter chord line is also chosen as a reference line. In this case, what is quarter chord line? From the leading edge quarter chord location. Usually thinking as it's an aerodynamic center. So that line is called as quarter chord line. Just mark it as I show in the picture also. From the leading edge, there is a quarter chord line. Either you can take the reference or leading edge is also okay. This reference also, it doesn't make much difference in the argument. Look at what I am trying to bring in. So usually the angle measured with respect to what? A horizontal line parallel to this and quarter chord line is the angle. Or otherwise it is the same thing. You can make it like this. It is convenient. Everything is okay. Now look at the argument. And line that is to measure this with swept back angle. One fundamental thing that it is component, write down component of free stream velocity. Component of free stream velocity normal to the quarter chord line. Normal to the quarter chord line. To this line. Both are parallel almost. Okay. Normal to the at one particular mean location. That's it. Here also at one. Understand the point. Component of free stream velocity normal to the quarter chord line. What is this point? Looking at this picture, suppose if I mark parallel line, free stream velocity, see the effect actually. This particular V is not perpendicular to leading edge line or quarter chord line. It is not perpendicular. V infinity vector is not perpendicular to the. Why this perpendicular nature suddenly I brought the picture? Now look at it. This is the straight wing. This is the V infinity. The dynamic pressure on the wings is strongly governed by the V infinity, which is perpendicular to the leading edge line or quarter chord line. That is the main contributor. Suppose wing sweep is given, swept back is given. This V infinity is not perpendicular to the quarter chord line or leading edge line. So its normal component, well, V infinity free stream velocity component normal to the quarter chord line is the one which decides the dynamic pressure acting on the wing. In this case, there is no problem. In this case, V infinity is completely perpendicular to leading edge line or quarter chord line. So total dynamic pressure acting on the wing is completely decided by V infinity. But in this case, component of V infinity normal to the quarter chord line should be calculated. That is the dynamic pressure calculation. That is the dynamic pressure. Please write. Component of free stream velocity. This point, if you understand, the problem is understood. Okay. Component of free stream velocity normal to the quarter chord line mainly decides the aerodynamic forces acting on the wing. Mainly decides the dynamic pressure, in turn results in aerodynamic forces. Mainly decides the aerodynamic forces acting on the aircraft. More especially the wing. Now let us try to write those components. Now we try. Resolve this V infinity with respect to line normal to this I want this component in terms of V infinity. Theta is there, capital lambda is also there. Now this is the right wing. What is right wing? This one is not. When I write something on the board, it is everybody's right. But I also write like this only. My view is also like this. So it right means, including instant it is right. But when I am standing like this, to my right, not to your right. When I write something on the board, it is general to everybody, instructor and audience direction. Okay. Now look at this, because I identified a momentum, the location of the layer of symmetry. Here also, parallelly V infinity please qualify. Look at the vector notation. That is very, otherwise you will not understand. V infinity line is there. Now on both the sides we should write component of V infinity normal to the quarter chord line. Right hand side, how do you write? Right hand side and left hand side. This is not the one, this is the V infinity. How do you resolve this? Parallel. And other perpendicular is what? This way it will come. Not this way. When you resolve the vector, how do you resolve the vector? This is parallel to quarter chord line, and this way is only the line perpendicular to quarter chord line. Look at the vector. How do you resolve the vector? So how do you write it? At one particular point. What is the component of V infinity perpendicular to the quarter chord, and how do I write? Do I write this way or this way? What is the representation? Please tell me. Please make a sketch. Parallel. Because of the wing sweep back nature, something is happening on the wing. Right wing and left wing, they will experience something differently. What is this value? Look at here. What is this value? V infinity cos lambda minus beta. What is this component? V infinity cos lambda plus beta. Both the angles are different. Lambda minus beta, lambda plus beta. Right now. The component of free stream velocity is normal to quarter chord line on two wing halves. Will be equal or unequal. The component of free stream velocity is normal to the quarter chord line on two wing halves will be unequal. Same free stream velocities are not experienced by both the wings because of the wing sweep, which is the higher value. Cos lambda plus beta. So what is the higher value among these? It appears plus, right? Cos lambda plus beta versus V infinity cos lambda plus beta, V infinity cos lambda minus beta. This is on the right wing, this is on the left wing. This is the free stream velocity we have to consider to calculate the aerodynamic forces. Which value is higher? Right wing experiences the on the unequal V infinity cos lambda minus beta on the right wing, Write down this. V infinity cos lambda minus beta is on the right wing. V infinity cos lambda plus beta on the left wing. This will give you an idea now. Though we do the derivation part, you can even understand even now. So, at the same angle of attack, both the wings experience unequal dynamic pressures. Because dynamic pressure is completely dictated by component of free stream velocity normal to the quarter chord line. So, which wing is experiencing more dynamic pressure? In this case, right wing compared to left wing. Which wing will generate more lift? Right wing. Then the left. Net effective rolling moment will be which direction? Towards net rolling moment. Net rolling moment. Lift is more here, lift is less here. What is net rolling moment? Left. Already wing is in aircraft is in what orientation? Roll to right. Because of wing sweep, this wing experiences more dynamic pressure, less dynamic pressure. Because of wing sweep, this wing experiences more lift, less lift. Already roll to right. We are expecting a roll back. Effective rolling moment is a roll back, negative rolling moment. This way it will come. So wing sweep creates restoring rolling moment. When there is a disturbance in the rolling moment, wing sweep also contribute towards restoring rolling moment. But how much it is, we will see. Dihedral is the major contributor. Okay. So let's write a formulation now. Right now. If the two wings experience unequal dynamic pressures, and drag force also will be what? Here itself I can conclude some point. Which wing will experience drag force? Roll to right creates air to left. Now look at the drag point of view. More lift, which is like this. More drag. More lift. Effectively eye movement, net eye movement will be in what direction? So this particular one will be more fascinating for both directional stability and lateral stability. Same effect. Okay. The difference in the normal velocity components would result in lift on the two wing halves being different in this case. Lift on the two wing halves being different in this case. Okay. This quickly we should be able to write the coefficient of rolling moment due to the wing sweep. Write down. Rolling moment on the right wing due to wing sweep is equal to. We don't need elemental strategy here. It's not needed. Right now, right wing, rolling moment created. What is rolling moment? Lift into momentum. How do we write the lift on the right wing? Like we have written in the last class. CL, half rho into V into square, S. Here S is S by 2. One right wing only, half of the wing. S is, please write the format, rolling into Y bar. Y bar is the momentum. What is the rolling moment created due to the wing sweep on the right wing? Is it positive or negative? L prime R. Lift is created. This rolling moment is positive or negative? Positive. moment it is through the axis seen, positive x-axis. It is clockwise or counterclockwise. This creates. This lift creates clockwise. So this is negative. Rolling moment created by the left wing, right wing is negative. So minus of CL half rho infinity. What is V infinity square term? Right wing. V infinity cos lambda minus beta. Cos square and V infinity square. Half rho infinity square. CL is gone. Then S by 2. Momentum. Rolling moment, left wing, plus CL, half, rho infinity. What is the free stream velocity? V infinity square cos lambda plus beta whole square, S by 2. Net rolling moment, sum of both. Right now. Minus of, please write like this, minus of here, because you will return it minus. So that negative rolling moment is created because of the positive disturbance. So let's write this formula and summation. What and all you can bring out? Half rho infinity V infinity square S by 2 4 cos lambda cos beta sin lambda sin beta. Right? So this is what? What is this further simplification? What is sin 2? Because now look at it, one change I think. Small angles of beta. Cos beta is 1. Small angles of beta, sin beta is beta. So beta can be there. What is left? 4 cos. What is this? 2 sin 2 lambda 2 here yes by 2 is gone 2 sin cancel out this. Tell me the final version. Why do you only can to write as a bearing? Minus CL, yes, y bar, half rho infinity V square beta sin 2 lambda. This is the amount of restoring rolling moment your wing sweep of certain angle is going to create for this particular beta, for this particular V infinity, for all the ones. This will give you amount of rolling moment that wing sweep configuration would try to create. That but the rolling moment is negative for the positive disturbance. So wing sweep is a stabilizing contributor towards roll stability. That much we understand. Amount also we can calculate. What is the stability criteria? Stability criterion, only one. dCl prime by d beta is equal to minus of Cl S one minute. Convert into Cl. Convert to Cl. What is Cl prime? Coefficient of rolling moment divided by half rho infinity v infinity square. What is the point now? Coefficient of rolling moment, please write. That is L prime by half rho infinity v infinity square S into V. Finally, what is the point? Minus of Cl y bar by B, y bar by B, beta sin. This is the amount of coefficient of rolling moment generated by wing sweep. What is the criterion of roll stability? Minus Cl So here certain points we need to understand. So contribution of wing sweep or a swept back is a stabilizing contribution towards roll stability. Please write. Because it is satisfying the criteria. Negative. Level of roll stability can be understood by these parameters. What is the strongest parameter? I will tell you. So wing swept back contribution is stabilizing towards what? Roll stability. Please write that one. Why swept back we are claiming? What about swept forward? Swept forward. So wings are at near length. Forward. This is swept back. So wing sweep forward, angle negative, makes it to be